guys, Miss Miklos here with our exciting beginning of Chapter 5. Chapter 5, we are going to kind of delve into some new concepts. And this entire chapter, we are going to be working with what we call quadratic functions. Okay, and what a quadratic function is, this is what we call the standard form. F of x, which we know means the same thing as y, equals ax squared, and this squared is really what makes this quadratic, plus bx plus c. So this squared is what makes it quadratic. And I want to start by talking about what we call a degree. A degree is the highest exponent in a function. So in this case, clearly it is 2. And what the degree tells us is the number of zeros. And we'll get more into this term in a second, but just kind of know this is a huge concept. Definitely something you guys are writing about in your responsive writing, something we see later on in subsequent chapters, and also something we see in pre-calculus at the next level. Just to kind of give you guys an idea of what zeros are, we also refer to them as X-Intercepts. And in fact, X-Intercepts are only our real zeros. And yes, we will learn about things that are not real this chapter, or what we call imaginary. We also refer to zeros as roots. So these are all terms that are somewhat interchangeable, okay? And when we get into an actual example, we'll see a little bit more about a zero. So a little preview of this particular chapter. We are going to be learning 4 different methods that we can use to solve quadratic functions. Some of them, in fact, I think 3 of them are ones that you guys will have previously learned, but one of them will be brand new. We're also going to learn how to graph quadratic functions, which is going to be a new concept for all of us. And we're also going to learn how to solve real-life problems. And I know we're, as always, very excited about word problems there. So today's specific lecture is on solving by factoring. And just so you are aware, everything that we're talking about today is actually factoring review from Algebra 1. So I know we've talked about this previously, but if you know that you maybe didn't have the best Algebra 1 experience, or if this was something that you struggled with in Algebra 1, you need to make sure that you are coming in and getting additional help, because I am treating this topic as if we are simply reviewing it. It's stuff that we have previously learned. So whenever we are factoring, the very first thing we should always look for is what we call a GCF, which represents greatest common factor. So let's say we have something like 6x squared minus 6x. I can tell that we have a common factor in both of these. In fact, I think the greatest common factor that I can take out of both of them is a 6x. So I'm taking a 6x out, and I need to figure out what am I left with inside. So let's think for a second. If I took a 6x out of 6x squared, I am left with just an x. And a way to double check this is to distribute. 6x times x is 6x squared. When I take a 6x out of negative 6x, I am left with negative 1. And once again, if I distributed this, 6x times negative 1 is negative 6x. So this is the first thing that we always look for. Just because I can take something out does not mean we are done factoring. I would need to look inside my factor here to see if there's anything more that we can do, and in this case there's not. Big thing though, I can double check by distributing. Second thing we look for are patterns, and there are 2 major patterns that you guys should be familiar with. Our first we call difference of squares, and this pattern comes up a bunch, and it actually makes our lives much easier. That is when we see a squared minus b squared. So notice we have 2 perfect squares, and we have subtraction in between them. And the way that we factor this is a plus b times a minus b. for example, if I had something like 9x squared minus 16, there's not a common factor here, but I noticed that 9x squared is a perfect square. In fact, that would be 3x squared. I also know that 16 is a perfect square, so I'm going to have 3x plus 4 and 3x minus 4. The way that we can double check this is by using FOIL. First, outside, inside, last. So let's do that real quickly. I get 9x squared minus 12x plus 12x, which cancel each other out, minus 16. So we get 9x squared minus 16. Our next pattern is what we call a perfect square trinomial. We know trinomial means that we have three terms. Perfect square refers to the first term and the last term being perfect squares, and this type of trinomial we can write as a binomial squared. So we have a squared plus 2ab plus b squared, and our second one is almost exactly the same. The only difference is it's minus instead of plus, and it ends up being the quantity a plus b squared, or if we have a minus here, the quantity a minus b squared. The significance about this middle term is that it is twice the product of the square roots of the first and last term. So if we look at this problem here, I notice we have a trinomial. X squared is a perfect square, 4 is a perfect square, and let's just think of it. The square root of x squared is x. The square root of 4 is 2. So double 2 times x would be 4x. So that tells me this fits this pattern. So I know it's going to be x and a 2 squared, and I'm going to put a minus because of this minus sign right here. So those are our two patterns. I would say definitely the one we use the most is difference of squares. Perfect square trinomial is helpful. It definitely saves us time. But if we don't catch it, we can go ahead and factor that using our third and final method of the day. So our final method is what I like to call opposite of FOIL, and that is when these first two things do not apply and there's more that we can do. So this would be an example like x squared minus 12x minus 28. I definitely do not have a GCF. This is a perfect square. This one, though, is not. So I'm going to try opposite of FOIL, which means instead of FOILing everything out, I'm trying to factor it into two binomial factors. So first thing, I need to figure out what multiplies to be x squared. And I know my only options would be x and x. This would be an example of a really easy problem. Now I need to think, what are factors of negative 28? So I am going to go ahead and list them. We can do 28 and 1. Obviously 1 would be negative, 1 would be positive. We could do 14 and 2. I could do 7 and 4. And I think that's about it. Now obviously one of these has to be negative, one is positive because it multiplies to be negative value. So I have to think, do any of these options add up to be negative 12? And I think if we did negative 14 and positive 2, that would work. Now, in order to check this, all I really need to do is double check the outside and the inside. So let's do this. 2x minus 14x is negative 12x. So we're good. Let's try this on a tougher one. So here's a more difficult one because we have a leading coefficient that is different than 1. So 3x squared minus 17x plus 10. A good helpful hint, just to double check if something is factorable, is to multiply this leading coefficient by the constant and see if there's factors that would work. What I mean by that, 3 times 10 is 30. I know some factors of 30 would be negative 15 times negative 2, which add up to be negative 17. Now that tells me that this is factorable. So when I'm factoring this time I need to think what can multiply to be 3x squared. My only option would be a 3x and an x. Okay, if I think about 10, I know we could have 10 and 1, I could have 5 and 2, and that's about it. So, and they could also be negative. I need to think, when I put them in here, when I multiply the inside here and the outside, will they multiply to be negative 17x? So I'm thinking maybe minus 5 and minus 2. So let's check. Negative 15 minus 2 is negative 17. My hint to you guys, and this will make sense when we're dealing with our equations, I always keep the x squared term positive. In my opinion, it makes it much easier to solve. Okay, so before we get into our real problems, we're just going to do a few quick factoring ones. In fact, it might be good if you pause this video and do these two on your own just to see how you're doing, and then press play. So this first one, I know first thing I always look for is a GCF, and it appears that I can take a 5 out of everything. When I take a 5 out, I'm left with x squared and negative 4. Now, just because I took a GCF out does not mean I'm done. I notice x squared minus 4 fits my difference of squares pattern. So this would become 5 times x plus 2 times x minus 2. Secondly, 6p squared plus 15p plus 9. Once again, I notice that I have a GCF of 3. So I'm left with 2p squared plus 5p plus 3. Now this doesn't fit a pattern, but I'm going to just check, does it fit opposite of FOIL in some way? I know the only way I can get 2p squared is by doing 2p and p. 3, I think we're going to do 3 and 1. So let's see, let's try plus 3 and plus 1 and double check. 3p plus 2p is 5p. So this would be our final answer. These are the level of difficulty that I would expect that we are pretty good at doing. Once again, if you need more help on this, come and see me and I have some additional resources that I can give to you, or email me and I can email you some additional resources. Once we factor, what we're going to do is set each factor equal to 0 and solve. So I wrote out an equation here that's already factored, and notice that it is equal to f of x. So the first thing that we're going to do here is set f of x or y equal to 0. And if we just think about it, if I'm multiplying two things and their product is 0, that means one of these or both of these have to equal 0 in order to get this product. So I would say x minus 2 equals 0 and x plus 1 equals 0. So I would get x equals 2 and x is equal to negative 1. Okay, these technically are our answers. Now, what we really did here is we found what we call the zeros. Now, what this is representing, I know when y is equal to 0, we call those values X-intercepts. So if we went ahead and looked at this on a graph, this is what we would see. So obviously today we are not graphing, okay, but I just want to point out where our x-intercepts are. And this is at 2, 0, and this is at negative 1, 0. And those were the two values that we found when we solved this. Okay, so there's definitely a connection between our answers and where it crosses the x-axis. So the whole point here, we call these zeros because our y value is set equal to 0. Okay, so now we're getting to our real problems. Since I'm solving this, first thing I'm going to do is set it equal to 0. And now I'm going to try and factor this. So first thing I'm looking for, do we have a GCF? And we don't. It does not fit one of our patterns, so I'm going to try opposite of FOIL here. So I need to think, what factors of negative 18 add up to be 3? So I'm thinking maybe positive 6 and negative 3. So let's double check this. 6x minus 3x is 3x. So I know that that works. So I'm going to set both of these factors equal to 0. And I get x is equal to 6 and x is equal to 3. It would make sense that we have two answers because our degree is 2. We know quadratic functions have a degree of 2, and that degree tells us the number of zeros that we are going to have. Okay, here is example number 2. We will definitely see some like this. First thing I need to do is get this set equal to 0. So I'm going to go ahead and subtract 3x from both sides and add 5 to both sides. And I notice that there is a 2 in everything. So I'm going to take a 2 out. And as soon as I take that 2 out, some things jump out at me. I have 2 perfect squares. Okay, so I'm thinking to myself that this might be like x minus 5 squared. And let's just double check this for a second. Okay, is negative 10 double the product of x and negative 5? And it is. Now, if I forgot about that, then what I could go ahead and do is just use opposite of FOIL and think what factors of 25 add up to be negative 10. So now I need to set these equal to 0. Okay, we haven't really talked about dealing with a squared yet in solving. We're going to do that next time in our very next lecture. I know though something squared is writing it as it's multiplied by itself. So I'm going to go ahead and set all of these factors equal to 0. And something kind of weird happens here. In my first one, I don't have an x, so I don't need to worry about that. Then I get x equals 5 and x equals 5. This seems kind of weird, but just so you guys know, this is actually what we call a double zero. And I'm going to show us a graph of what this looks like, just so we are aware. And if we look at this graph, we notice that what happens, I'm going to say it bounces off of the x-axis. Okay, so this is just a little preview as to what a double zero does in our graph. Okay, so problem number 3. First of all, I just want to stress that on this assignment, you guys do not need to graph anything. I'm just graphing so you can see eventually where this is going to connect. Also, one thing I want to point out in directions, whenever we have an equal sign, it will say solve because that means we're actually solving for x. If I just have an expression, I cannot solve, so that's when it would just ask us to factor. So number 3, I need to start by getting this set equal to 0. And as I said earlier, I like to keep x squared positive, so I'm going to move everything to the right side. So when I subtract 3x, I get negative 3x, and when I add 6, I get minus 4. So when I'm factoring this, first thing I'm looking for is, do we have a GCF? And we don't, because there's not a common factor in these 3 terms. So if I'm factoring it, I know x times x makes x squared, and I need to think, what are the factors of negative 4? And I'm going to try negative 4 and positive 1. And let's just double check, outside and inside. 1x minus 4x is negative 3x. So now I'm going to take both of these factors and set them equal to 0. So I'm writing x minus 4 equals 0 and x plus 1 equals 0. And when I solve, I get x equals 4 and x equals negative 1. And those would make sense because my equation up here is quadratic. And we know this 2 means I should have 2 answers. Looking at number 4, you might be excited because it's already factored. Unfortunately, it's not set equal to 0. So I need to start by unfactoring or foiling this. So when I multiply, I get 3x squared plus 5x minus 12x minus 20 equals 4x. So looking on the left, I have some like terms that I can combine. So I'm going to add this and I get minus 7x minus 20 equals 4x. And now I know I need to subtract 4x from both sides. So I get 3x squared minus 11x minus 20 equals 0. So I need to look and see, do I have a GCF? And we don't. So I know I need to use opposite of FOIL. The only way we could get 3x squared is 3x and x. So let's try some factors of negative 20. I'm thinking maybe positive 4 and negative 5. And let's just check this outside and inside. Negative 15x plus 4x is 11x. So it does work. Some of you might be wondering, well, what if this wasn't factorable? And guess what? On every single problem on this assignment, we are only solving because it is factorable. Eventually, you will need to choose a method that is easiest. I think factoring is actually one of the easier of our 4 methods, but unfortunately, it does not always work. So now I'm going to set these factors both equal to 0. And I keep using this term factors. This is what we call a factor. Okay, hence factoring is writing it as a product of factors. So when I solve this, I get 3x equals negative 4. So x is equal to negative 4/3. And I also get x is equal to 5. So I know that those are my 2 solutions. Those are my 2 zeros. Or we could think of them as x-intercepts or roots. Final problem. Once again, I'm going to have to start by getting the set equal to 0. So I'm going to subtract 30w from each side. And sometimes when we see something like this, it stresses us out, but we need to remember that I should always begin by looking for a GCF. And I can see that I can take a 5w out of both terms. So when I take 5w out of the first term, I'm left with w. Just to check, 5w times w is 5w squared. When I take 5w out of the second term, I'm left with minus 6. And I know 5w times negative 6 is negative 30w. So now this is factored into linear factors. Linear means that my degree is 1. And this one's a little bit different. The previous problem where we had a GCF, I just had a number, so we couldn't solve because we did not have a variable to solve for. Here, I would divide both sides by 5, and I would get w equals 0. And then my other equation gives us the answer, w equals 6. Once again, I have 2 answers, which makes sense with our degree of 2. So this is solving by factoring. Once again, as I said earlier, I think this is one of the 2 easier methods. If you need more help on this, please let me know. Please come in and see me. I have some extra assessments that I can give to you for practice if you want. But this just gives you a little taste of what factoring looks like.